So what we have here is we have 8 graduated cylinders filled with different indicators. Here we have universal indicator, phenol red, universal, thymol blue, and thymolphthalein. A pH indicator will indicate the pH, obviously. Right now we have them all basic, so they all show a basic pH. As the pH changes, the color of an indicator would change. Some indicators have a narrow range that they change over, and some have a much larger range that they change over. So what we'd like to do is we'd like to add some dry ice, which is acidic, and we'll see how that changes the pH. And we can see here that these have already changed, showing that they have already passed their point where they go through a color change. We can see that we've gone from a blue to a clear. Here we have sort of the yellow color, and here we have more of a teal color. When the dry ice, which is solid CO2, is added into the water, it forms carbonic acid, which is a weak acid and will react with the base in the water, the hydroxide. We started off with 6 molar ammonium hydroxide, and they will neutralize each other, and if there's an excess of CO2, we form an excess of acid, which will turn our pH more acidic and will lower it by much more. And that's why we see the color changes, which are very distinct from between their acidic pH and their basic pH. So if you were watching, you may have noticed that some of these indicators went through many colors, especially this one, and this one also went through a few colors. This one went through at least 3 to 4 colors, and that's the work of multiple acid-base combinations at work, and that can be very useful for getting a solution to a specific pH. Okay, so after we've already emptied these out, we still get a little carbon dioxide gas left in here, and since carbon dioxide gas is actually heavier than the normal air, it's just going to sit in here. And something fun we can do is with a vacuum, we can see it being sucked out.